everyone, this problem has been asked in GATE 2023 and this problem relates to the control system subject, and the problem says that consider the state space description of an LTI system with matrices A is equal to 0 1 minus 1 minus 2, V is 0 1, C is 3 minus 2, D is 1. For the input sin omega t, where omega greater than 0, the value of omega for which the steady state output of the system will be 0 is, and the answer should be rounded up to the nearest integer. For the detailed analysis or for the detailed background, how we get the transfer function from the a state space representation or model, you can refer this NPTEL lecture. A state space representation part 2, and the NPTEL course name is Control Systems by Professor C.S. Shankar Ram, Department of Engineering Design, IIT Madras, and the YouTube link is given below. Now before we begin to solve this problem, let us have a quick recap of the expression for this transfer function for the state space model. As we all know that a standard form of a state model is x dot is equal to ax plus bu, and the output equation is cx plus du, and the first x dot is equal to x plus bu is called a state equation or dynamic equation, where x dot we called it as differential state vector, y we called it as output vector, A is called as a state matrix or system matrix, V is called as input matrix, C is called as output matrix, D is called as transition matrix. Now if we want to find the transfer function from the given state model, we will use this expression. Transfer function Ts will be Cs minus Si minus A inverse into B plus D. And we also know that determinant of Si minus A is equal to 0 will give the characteristic equation, and the solution for the characteristic equation will give us poles or roots or eigenvalues. Now let us be solve this problem. So as we all know that transfer function is denoted by this expression Csi minus A inverse B plus D. First, we will find the matrix Si minus A, where I is the identity matrix. S be represented like this, I be multiplied with identity matrix, and then we will get S00S minus A is given in the question. So we will get S minus 1, 1, S plus 2. Now we will take the inverse of this matrix. So we all know that how to find the inverse of 2 cross 2 matrix. This diagonal elements will just take taken the place of each other, and this another non-diagonal elements will get multiplied with minus 1, and the determinant of this matrix will get at the denominator. So we have found out this Si minus A inverse. Now we will find this S minus A inverse multiplied with B. So B is given in this problem. So on multiplying S I minus A inverse into B, we will get this expression, this matrix 1 divided by S plus 1 whole square, and the second element is S divided by S plus 1 whole square. Now taking all of these terms CSI A minus A inverse B plus D, we will get the final transfer function. So Ts will be 3 divided by S plus 1 whole square minus 2S divided by S plus 1 whole square plus 1. Therefore, on simplifying this problem, we will get 3 minus 2S plus S square plus 2S plus 1, S square plus 2S plus 1. This 2S will get cancelled out. Therefore, we will get Ts is equal to S square plus 4 divided by S square plus 2S plus 1. Now we will put the S is equal to j omega. So this Ts will become Tj omega, and the expression will become minus omega square plus 4 divided by minus omega square plus j 2 omega plus 1. Therefore, this output will be 0 for omega square minus 4 is equal to 0. Therefore, omega is equal to 2 radian per second. And in this problem, it has been asked that for the input sine omega t. Since this sine omega t, if we take this input sine omega t, so this the magnitude of sine omega t will get multiplied with this tg omega for the final output, and the phase of sine omega t function will get added up to the transfer phase of the transfer function. Therefore, since this t j omega become 0 at omega is equal to 2 radian per second, this will also become 0 for the input sine omega t. Therefore, we can say that the final answer for this problem is omega is equal to 2 radian per second. That's all. Thank you.